Yeah, I think we'll start today. So we have seen what is embedded systems and the different types of number systems and all those things and how we can convert them from decimal to binary, decimal to hex, and binary to hex, and vice versa. And what is the microprocessors basically, and what is the use of microcontrollers with the real-time examples we have seen it, and how about the difference between both of them also we try to understand them. So most probably today we'll see what kind of different architectures we are having. So mostly we will be going through not in detail about all these differences. I will be just giving the overview of them why because it's nowhere needed in the software development for us. And little bit of the 8051 microcontroller basics we will give, and we will see the microcontroller peripherals like what is the timers, what is the watchdog timer, what kind of interrupts it will have, how the power supply will happen, what is the GPIO pins and all those things. And then we'll see the memory organized. Anyhow, we saw yesterday in the microcontrollers what is the RAM and ROM, but still there will be some other different kinds of memory still in the microcontroller that we will be seeing it. And if time permits, then we'll see the embedded systems in automotive, how exactly we are using the embedded systems in automotive. So guys, does anyone having any doubts in the yesterday's class? Hello?
Yeah, no.
Fine. Okay. Then let me proceed for today's class. So, what is the topic? So basically what will happen, where is this notepad? So in the microcontroller, we are having the CPUs, right? We are having CPUs, right? So this CPU development is there, right? Hardware development. So this will be happening in the two ways of architecture. Okay, see how if you are doing any of the product. So for that product, there must be some architecture actually. Architecture in the sense how we were going to proceed that development. Either it is a product development or the software development. There must be a design for that development. So without the design, we cannot do anything. That means that we can do something, but it will not be the relevant or something. It may go out of the scope as well. So that's the reason all these things will be having some kinds of architectures, we can say. So if you see in the civil constructions also, right? In the civil also, we will have first what we will do. Can anyone tell me? We will have the planning. Then only we'll start the construction, right? So in this planning, there will be architecture plan also. Correct. So the same way here also for developing the microcontrollers, we have the different kinds of architectures actually. Architectures. So to develop that microcontroller, So basically we will be using two kinds of architecture. One is for the CPU development, and the other one is for the memory utilization. So if you see here, the CPU architecture, basically it will be two kinds actually, Harvard and the Van Neumann architectures actually. So let me take this example. So, if you see here, this is the Harvard architecture, okay? So in this case, the Harvard architecture mainly it will be distinguishing how the memory, memory segregation is going to happen. Okay, this case for the instruction and the code, we will have the different, uh, different kinds of memory. Where is the other one? So this is the Van Neumann. You can see here in the diagram itself, Van Neumann. So in case of Harvard architecture, so guys, you no need to remember, okay, what kind of that microcontroller is coming with what kind of architecture and all those things. You no need to remember. If you really want it, you can go to any of the microcontroller data sheet. So each and every microcontroller will come with some data sheet. Okay, that data sheet in the sense, data sheet means it will have all its properties. So what kind of architecture it is having, what kind of memory it is having, what kind of peripherals it is going to support, and what will be the voltage levels, power supply ranges, what it can access, and what is the pin configuration, and what kind of interrupts it will support, and how about like uh, what else it will come. So all this kind of information it will come in the data sheet. Okay, no need to worry about all these things. So if anyone asking you what kind of your microcontroller is having, let me show you one of the data sheet if I am having readily available. This LPC is the one of the PIC microcontroller is there. Okay, this is a PIC microcontroller data sheet. It is from the microchip, not from MOS chip. It is from the microchip. Manufacturer is the microchip. So PIC16F87X is the microcontroller. Okay, so you can see here this data sheet will be giving how many pins it is having. I cannot write on the PDF actually. So you can see like this is the pin diagram. How many pins it is having? Each pin, what does that mean, and all those things it is giving. So what kind of peripherals? How many timers it is supporting? And what else? 10-bit multi-channel analog to digital converter, analog to digital. These peripherals again we will be seeing it. Okay. So all those things it is already specified here. Okay, so you can see the here memory architecture also. You see this PIC family is having different microcontrollers actually. PIC 16F873 is the one microcontroller. Sorry, PIC 16F874 is the other microcontroller. 876, 877. So there are different microcontrollers. Okay, so all of them. What about the operating frequency? Resets, how it will happen. Flash program memory means like the ROM, and data memory means RAM.